All right, so today is 9.4 day 2. It's nothing new today. It's more just checking to see that you know how to do these problems. So what I would suggest you do is go through, there are 7 problems on lesson number 8 for 9.4. Go through using your notes from yesterday and try to solve some of those problems. And how this is going to work today is I'm going to put a problem on the screen. I'll give you what the solution should be. If you got them right, just fast forward the video and go on to the next problem. Check your answers and kind of keep doing that. If you get any wrong, keep watching the video and watch me work through the solution. This should save you a little bit of time, especially if you feel like you've got this down. And then you can also pick and choose which problems you end up doing. All right, so for our first problem, cosine of 2x minus sine of x equals 1. Your solutions that you should get for this one are, let's see here, you should get x equals 0, pi, 2 pi, 7 pi over 6, and 11 pi over 6. You should get those 5 solutions. So if you got that right, fast forward the video and you can go ahead and check the next one. If you did not get those right or you're missing some solutions, stick with me here and go ahead and watch me go through this. So cosine of 2x, we're going to use an identity for that, and specifically an identity that will involve sine. So if we look at our formula sheet, the double angle identity for cosine that involves sine is 1 minus 2 sine squared. So we're going to replace that cosine of 2x with 1 minus 2 sine squared. And then don't forget that minus sine x equals 1. Then we're going to subtract 1 from both sides to get negative 2 sine squared of x minus sine of x equals 0. Now, as you can see here, both of these terms have sine in common, so we're going to factor out a sine. So this will become sine of x times negative 2 sine of x minus 1 equals 0. Now, since this is 2 factors equal to 0, you set each factor equal to 0. So you're looking where sine equals 0, and you're looking where negative 2 sine x minus 1 equals 0. Sine is equal to 0 at 0, pi, and 2 pi. And then this negative 2 sine x minus 1, we are looking where sine of x equals negative 1/2. Sine of x is equal to negative 1/2 at 7 pi over 6 and 11 pi over 6. So that's where our 5 solutions come from for this example. All right, so your solutions for the second problem should be 3 pi over 8, 7 pi over 8, 11 pi over 8, or 15 pi over 8. So if you were missing some solutions there, it's because this one ends up being a tangent problem. So you might want to follow up here and watch this. If you got all those solutions, you can go ahead and on to the next one. So this is one of those we did like yesterday, and we're going to want to get this to be a tangent problem. And how we're going to do that first is by subtracting cosine of 2x from both sides. What this allows us to do is get sine of 2x equal to negative cosine 2x. So what we're going to do is divide by a cosine of 2x. So then we have sine of 2x over cosine of 2x equals negative 1. Now what we've done here is this sine over cosine is equal to tangent, and since our frequency is 2, this is going to be equal to tangent of 2x equals negative 1. Then from here you should be able to use some u substitution, so u equals 2x. So we're looking where tangent of u is equal to negative 1. Tangent equals negative 1, or u, will equal, let's see, negative 1, 3 pi over 4, and 7 pi over 4. Now, since our frequency is changing, this is where we have to take into account the period. So we're going to add pi k. So when we get 2x equals each of these, you're going to add pi k and then divide by 2. So x equals 3 pi over 8 plus pi over 2k, and x equals 7 pi over 8 plus pi over 2k. Now, pi over 2 is 4 pi over 8, since we are 3 pi over 8 and 7 pi over 8. So we're going to add 4 pi over 8 to these. So for our solutions here, if we kind of work over in this direction now, we're going to get x equals 3 pi over 8 plus pi over 2, or plus 4 pi over 8 is going to be 7 pi over 8. Plus another pi over 2, or plus 4 pi over 8 is going to be 11 pi over 8. And then 15 pi over 8. And we can stop there because in this case 2 pi, if we think of common denominators, is 16 pi over 8. So that's why these 4 solutions have to all be included. And remember, that's just where we have a tangent problem where your frequency is changed. All right, for number 3, you should have gotten the solution x equals pi. So if you got that, go ahead and fast forward, check your next answer. If you did not, I will work through it here for you to show you. So here we have a half angle identity that's squared. So the half angle identity for sine is going to be plus or minus the square root of 1 minus cosine x over 2, and it's squared, plus cosine x equals 0. Then what we're doing here is we are squaring this square root. So the square root and the square cancel. So we have 1 minus cosine x over 2 plus cosine x equals 0. Now with these two terms, we could find a common denominator and put cosine of x over 2. What might be a little easier to think about is just multiplying everything by 2, because when that happens, 2 times this first term is going to cancel out the 2 on the bottom and just be 1 minus cosine x. Then we distribute the 2 to the cosine x, so plus 2 cosine x, and then equals 2 times 0, which is just 0. So since we've multiplied everything by 2, we've kept it balanced. Then from here, this negative cosine x and this 2 cosine x can be combined to be 1 plus a 1 cosine x. And then subtract 1 from both sides to get cosine of x equals negative 1. Now cosine of x is equal to negative 1 in just one spot, and that is at pi. So that's where our one solution of pi comes from. All right, so for example number 4, if you've already worked it out, you should have gotten 6 solutions. Pi over 2, 3 pi over 2, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So if you got all of those, go ahead and keep moving on. Otherwise, stick around here and we will go through this together. So here we have a couple of things going on. We have a double angle identity for sine, and then we have like a regular sine, a regular cosine. So what I recommend doing is, since the double angle identity for sine of 2x is just in terms of sine and cosine, we're going to rewrite that. 2 sine x cosine x. So that replaces the sine 2x, and don't forget that's all times sine x minus cosine x equals 0. So if we rewrite this, we actually have a 2 sine squared times cosine minus cosine equals 0. Now, if you look closely here, we have these two terms have a cosine in common. So this is going to be one of those that we're going to try and factor. So we're going to factor out a cosine. So you get cosine of x times the quantity of 2 sine squared of x minus 1 equals 0. So we take each of those factors and set them equal to 0. So cosine of x equals 0, and 2 sine squared of x minus 1 equals 0. So this first one is pretty straightforward. Cosine of x equals 0 at pi over 2 and 3 pi over 2. So that's where the pi over 2 and 3 pi over 2 come from. And then for this one, we're going to solve. So we get sine squared equals 1/2. Okay, this is sine squared of x. We want it to just be sine. So we're going to take the square root of both sides. So you get sine of x equals plus or minus square root of 1/2. And what we're going to do is simplify that square root of 1/2. So we're going to rewrite it as the square root of the top over the square root of the bottom. So that's equal to plus or minus 1 over root 2. And then you have to rationalize that. So this is actually equal to plus or minus root 2 over 2. So one important thing to remember is that the square root of 1/2 is always going to be equal to root 2 over 2. So in this particular case, we are solving for where sine is equal to positive or negative root 2 over 2. And that happens at all of your pi over 4 radians. So x is going to equal pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, so your two solutions for number 5 should be pi over 3 and 4 pi over 3. This is another one of those where we're going to want to turn this into tangent. Now, this one tends to throw people off because of this root 3 here, but don't let it. You're just going to, at first, leave that attached to the cosine. So what we're going to do is add root 3 cosine of x to both sides. So we have sine of x equals root 3 cosine x. And then what we're going to do is just divide by the cosine of x, so that you're left with sine of x over cosine of x equals root 3. Now the sine of x over cosine of x is going to become tangent of x, and that's going to be equal to root 3. And then this just becomes a simple unit circle problem. So where is the tangent equal to a positive root 3? That's going to be at pi over 3 and 4 pi over 3. And you can just use your unit circle to find those. Number 6, the solutions you should have gotten here were, let's see here, x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, so this one, we get sine squared of x minus 3 cosine squared of x. So this is going to be another tangent problem, okay? And that is because we can add this 3 cosine squared of x to both sides to get sine squared of x equals 3 cosine squared of x. Then we are going to divide by cosine squared of x. So we end up with sine squared over cosine squared equals 3. Now, we've done enough of these tangent problems. Hopefully you're kind of starting to see where this is going. So next we're going to look at, okay, if you're doing a sine over cosine, it's usually tangent. So sine squared over cosine squared is going to be tangent squared. And that's equal to 3. Now, just like with if we had x squared equals 3, tangent squared of x equals 3, we're going to take the square root of both sides. So we get tangent of x equals plus or minus square root 3. Now we just have to think, okay, where on the unit circle is tangent equal to positive root 3 and where is it equal to negative root 3? Well, that happens every time you have a pi over 3 term. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Tangent is positive here and here, and then negative here and here. So that's why there's 4 solutions, each of those 4 spots around the unit circle. All right, finally for number 7, x equals 0, 2 pi, and 4 pi over 3. Now this one is a little special. So you see the sign of x over 2, and you would be really tempted on this one to just use a half angle identity. If you do that, you would get plus or minus square root of 1 minus cosine x over 2 plus sine x equals 0. And I guess technically you could square both sides, but then you would have to, distribute the binomial over here on the left. And it might end up being a little more complicated than it has to be. So instead of doing all of that, we're going to use some u substitution and not actually use that identity in particular. So here's what we're going to do. I'm going to look at this and say, okay, let's just say u equals x over 2. So we would have sine of u plus sine of x equals 0. The only problem we're still running into is we have this as sine of x and this as sine of u. Well, all we need is to get this x here in terms of u. So in order to do that, we are going to take this and solve for x. So we'll multiply both sides by 2. So 2u equals x. And we're going to take this 2u and sub it in for that x. So we get sine of u plus sine of 2u equals 0. Some of you may see this now and some of you may not, but now we can use a double angle identity for sine. And if we do that, you get sine of u plus 2 sine u cosine u equals 0. And these have a sign in common, so we can factor. So sine of u times 1 plus 2 cosine u equals 0. And then we take sine of u and 1 plus 2 cosine u and set both of those equal to 0. Now, the only thing we have to remember then is that, okay, u is equal to x over 2. So here, when we get sine of u equals 0, well, that means u is going to equal 0, pi, and 2 pi. So that means x over 2 is equal to 0, pi, and 2 pi. So if we multiply everything by 2, that means we get x equals 0, 2 pi, and 4 pi. Now the thing to remember here is we're only looking in 0 to 2 pi, so we can leave off this extraneous 4 pi. All right, now over here on the other side, we are looking where, let's see, cosine of u equals negative 1/2. So that means we're looking where u is equal to, cosine is equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. So that's where x over 2 is equal to those two things. And then we multiply everything by 2, so we get x equals 4 pi over 3 and 8 pi over 3. 8 pi over 3 is larger than 2 pi because 2 pi would be 6 pi over 3, so that's going to be extraneous. So that's why we only get these three solutions, 0, 2 pi, and 4 pi over 3. That one's kind of the special case because that's a type of like u substitution. It's double u substitution that we haven't used yet. But it's kind of an interesting one either way. So this is all done now. So I'm hoping you watched and were able to check your answers. Go ahead and answer the discussion question with a post on Schoology and finish up that 9.4 worksheet.